This is Thursday, NET-136. Finished up GUI, talked about processes, and did some command line topics. Alright, so we are currently, this is week 3, day 6, right? Yeah, hard to believe. Alright, take a look here. First of all, we talked a little bit about this idea of we have hardware, and then we have the operating system communicates with the hardware. Then we have a shell that communicates with the operating system. In Linux we're using, it's the bash shell. And that's where we do our command line. And then you can have a GUI communicate through the shell. Now there's a few things that filter, down through here. You might say, well, I'm actually dealing with the hardware when I'm using a keyboard, but the keyboard's communicating to software that's communicating to the OS. And there's utilities and so forth. But this image here with these layers is a good image to think of, because we protect the hardware and the operating system from some user out here looking at a GUI. The curriculum, starting the labs, people should be working on the labs now. 04 all the way up to 16. Those labs automatically assign 5 points. When you do the lab, you'll get a check mark. And there is no certain level, you don't have to get X amount of the lab correct or whatever. You just need to do the whole lab and you get your points. In fact, if you start the lab and work part way through it, you get your points, but you should still finish the labs. Next thing, process versus programs. We think of a program stored on the disk, if you want to look at it in this way, and then that moves in the memory. Then we have it stored here in memory. And when it's in memory and ready to execute, that's what we consider the process. Of course, the process then, of course, communicates with the processor, and the OS, manages that communication. We talked more specifically about processes in the last unit, but let's just take a look here. We have the user running a process, and then if that process needs to be blocked to run another process, okay, we can block it, then it can come back to ready, and then it can go back to being executed. Or we can create a process and it's ready, and then it waits before it can be executed, and then it might have to be blocked, has to wait, be executed, kernel communicates to the process that's waiting, and this creates all kinds of things that we're starting to talk about more in the course. So now we should, whoops, let me use it a little bit different here. So, have the idea of a process, okay? Next thing, we talk about synchronization of that process, and then we talk about scheduling. Because you got to think about it. And we have lots of processes that need to be executed, or instructions from those processes need to be executed. So how does the OS manage that? So these are some big steps. We don't need to know all the details, but we will talk about those. Okay, let's run through here. We talked about the path variable. You can look at that path variable. You can go echo $path. You notice it has to be all caps. And it'll show you the path variable. This is unique for different users. They're very pretty similar, but there's a few unique things about those. You can type ENV for environment. And that environment, that would show you then the environment. It will show you a whole bunch of variables and so forth for that particular user. We should be able to do these things now. Should be able to change directories. Should be able to make, delete directories. We should be able to copy files, move files, remove files. We talked about DHCP and your computer's getting an address. In the future, we're going to take that and make it a static address in the near future. So we looked at an example here at a user, class, password here, and we talked then today about checking to see if a particular service was up and running. We talked about these services because those are processes, right? They're in the computer. We can look at the processes. I'll add this here, right here. You go PS and then the switch. Whoops. Let me repeat that. AUX. You can type that at the prompt and I'll show you all these processes. So I'm going to show you some pictures of those here in a minute. So we can look at the status of a service. We can start. We can enable it so it always starts. We can disable it so it doesn't always start, like when the computer reboots. Alright, so this allows us to SSH into the device, and this is web services and so forth. We'll learn a lot more about those later on. Alright, now we have a whole bunch of screenshots. So, system start SSH, okay? And then system status SSH, and then it gives us all this information here on the status of SSH, being able to SSH into the machine. That would involve a secure access. Okay? And then we also did ifconfig, and it shows us that IF stands for interface. Let's see if I can write it here for you. Interface configuration, so we get IP address, we get the mask, here's the broadcast over there. This is loopback. We don't have to worry about that today, but alright, here's the MAC address on this particular computer. here we were looking at processes. The bash shell is running, and then I turned on gedit. It's an editor, and you can see that process number. And then over here is the owners, owned by Dirksen or Root. Okay, so you can see we have lots of processes, and they all have a number. And here's the tricky part. Not tricky, I said kill that process. And so it would actually stop gedit from running. Okay. On this page, I was just looking right. Oops, I don't want to do that. If you look, here's gedit. It was terminated. Okay. Here's another if config. Here, this shows processes. If you did a PS AUX with these switches, then it would show all the processes like we had seen on the previous screen. I added a user. I gave the user a password. You notice, in order to be able to do this, you have to be at root. Says it worked. Okay. See, I tried to add a user up here, but I was not at root. So I had to log in as root, gave my password. There we go. I could add the users. And you can experiment with this, but you got to be on a machine that you have access to the root. So that'd be your virtual machine. Your virtual machines, maybe a machine you own at home, or in the near future, the machines in the room. Alright, so here, start SSD, check the status. So this is, you can, what's called secured shell. In the Windows world, we use PuTTY to access secured shell. You know, you can download a PuTTY app in your Linux box. We might look at that here soon. Okay. It's active and running. And then we went through this process. So if you think about it, we created a user. Let me use a different color here. We created a user. Showed you that on the previous page. We made sure SSH is running, and now you can log in to that machine. Alright, that's it. We're going to do a few more things to the servers in the near future to allow us to access them, and we'll go over that in class. That is it.